Hello, everyone, and welcome to the virtual Eclipse Community Meetup. I'm your host, Kat Hirsch, and I work for the Eclipse Foundation in Ottawa, Canada. Today, we're officially launching the Eclipse Oxygen webinar series. This will include 6 webinars over the course of 2 weeks as we lead up to the 15th annual simultaneous release, which will take place on June 28th, 2017. Please visit eclipse.org/oxygen for more information. To become a member of the Virtual Eclipse Community Meetup, just follow the link in the description below the video and join the growing virtual community of Eclipseans. During today's virtual meetup, you can submit questions to the presenter in the chat box on the right-hand side of the YouTube live event. At the end of the presentation, we will reserve 5 minutes to go through those questions with the presenter, and I will be monitoring questions throughout the discussion. So if you do have any live questions you want to send to us, you can send them on Twitter at #virtualeclipse, or you can send them on the YouTube live event in the chat box. So now I will turn the stage over to our first Eclipse Oxygen webinar presenter, Mark Hoffman, who is the CTO of mTrail in Bern, Switzerland. Today, Mark's webinar will discuss EclEmma code coverage in practice.
Hello, Kat. Thank you for inviting me to this webinar, this great Oxygen series. I will now switch over to my presentation and screen. Okay, here we are. So you can see that? We talk about the EclEmma project and code coverage in practice. Why is this relevant to the Eclipse Oxygen series? It's because EclEmma, a tool which is already pretty old, became part of the Eclipse Oxygen release. More a bit about this later. And for the beginning, to get everybody on the same page, I want to quickly show you what the whole code coverage thing is about. So what we typically have today, we have some kind of application we develop, test for it. The tests in best practice are written in code like unit tests and can be executed automatically. So what the tests actually do, the tests validate the correctness of the application. So does the application fulfill the defined purpose? And there's another metric which you can apply to actually judge about the tests, and this is called code coverage. So what you basically do while executing the test, you record all the pieces of the code which are executed by the test, so you can verify the tests for completeness, and you can identify parts of your applications which has not been covered by your test suites. But before going to all the details, I want to take you to a short flashback, back in 2006. Because back in 2006, this is when, for me, and at that time, we had Eclipse 3.2, which was called Callisto. And I had the chance to work in a great team that built an application from scratch from an insurance company, and we tried to apply all the modern techniques of software development, and part of that was, of course, continuous integration. Here's how continuous integration looked at that time. We used cruise control. This is the fun user interface. You can see some metrics here, and also they had some nice diagrams here. The user interface is really like 10 years ago. Of course, we also measured code coverage. So during our builds, we recorded which part of our code has been executed by the tests, and we measured code coverage. This is an example by a library called EclEmma. EclEmma was the library at that time which could be integrated into your build to create code coverage reports. But what we actually wanted to have is we wanted to have it within our IDE. So before we even commit, before we even run the build, we want to see how good our tests actually behave and how good our tests actually cover the code we have written at the same time. It's to the development of the EclEmma plugin. EclEmma, the name comes from Eclipse, and Emma, the library I used at that time. And this was end of 2006 when we created this library. And we used it for many, many years in many projects. And I open sourced it end of 2006. And it got very popular quickly. So what happened is that we received 2 community awards in 2007 and 2008 for the best developer tool. And EclEmma was used very, very quickly on many, many projects. But there was a problem, as you can see here on the timeline. So we have a long timeline down here from 2004 to 2017 with a bunch of Java versions like Java 5, Java 6, 7, and now 8, and now Java 9. That for this great Emma library, there was only just a single release in 2005, and afterwards the project simply disappeared. So there was no maintenance anymore. Versions, and we wanted to have new features like branch coverage, and also the Emma library was primarily built as a standalone tool to integrate in your build with ANTAS, and it was not meant to be integrated, let's say, into an Eclipse IDE. This finally leads me to the question, so maybe we need a new way, a new code coverage library as a replacement for Emma, which can handle the new Java versions, and which also maybe can better be integrated into the Eclipse IDE. So this leads me to the development of the JaCoCo library. The first release was 2009. Fun fact that the first prototype I did on JaCoCo was on EclipseCon 2009, and I think Santa Clara at that time. And the first prototype was finalized in the flight back from the West Coast to Central Europe with all the batteries I had with me. But this was the first prototype. At the end of 2009, I was able to do the first release of JaCoCo. JaCoCo was a code coverage library, actually a tool to measure code coverage with lots of integrations. So we started with ANT. We also added Maven later. But as you can see on the timeline, we never took the work to actually migrate EclEmma to the JaCoCo library. This happened end of 2011. End of 2011, there was the first EclEmma 2.0 release, which was based on the JaCoCo library. As you can see here, and as you can still see, is that we never changed the name. The EclEmma name comes from the original Emma library, which was great at that time. But later, EclEmma was so common, so we never changed it to some other weird acronym. So why are we here today? We are here today because now EclEmma is also became part of the Eclipse project. Today, EclEmma was a separate project. All of the year, you had to install it separately to the marketplace. And now it is part of the Eclipse project, and we can, it is now integrated into several distributions, but more about this later. So that's so far for the timeline. But this is enough slides for now. I think we should have a look at EclEmma at work and do some demos and explore the capabilities of the tool. Let me switch to Eclipse Oxygen. This is the latest milestone build I just downloaded. And I started with some projects in here. As an example project, I actually used the JaCoCo library and 2 bundles of the JaCoCo library, just the core library and the test library for that. The JaCoCo project is very much structured as a normal Eclipse project, where you have one bundle with the actual code, another bundle with the test code. That's because I'm an Eclipse guy and I like to do it this way. So what you basically do when you run your tests, you just run it a normal way, like with the run or with the debug mode, whatever. And if you with the new Oxygen release there, or if you have installed EclEmma, there's a new button which launches your test or whatever under code coverage. So I just click the button here, and now the unit tests for the JaCoCo core library should be executed. Now we're starting here. We have something like 700 test cases. They run now under code coverage, which means that some magic behind the scenes, we will talk about a bit later, recording what has been executed right now. Down here, we have the code coverage view, which gives an outline of our project and shows the coverage, the amount of code which has actually been executed, and we can drill down to classes, to method level, whatever we want, and we can even open it in the Java editor. And in the Java editor, we get the direct highlighting of the code which has been executed. So you see each line which has been executed is green, and the project has pretty good test coverage, but some lines are actually missed, like this one. This return has never been executed. And you see a yellow line here and above. What means yellow? Yellow means here is we have some branches here. Of course, this is an if statement, and maybe we missed some here. Obviously, we missed the branch where this evaluates to true, and then there's no return statement. And here at the side, there's also a tooltip where we can see the missed branches. So this helps me to understand where I can improve my test coverage and where maybe I need to add more tests for these corner cases which are not covered yet by our tests. This is the typical use case that you run your test suite and afterwards get an overview about the parts of your code you missed with your tests. Another typical use case is that you actually work on a specific test or on a specific piece of code. If you do like test first and you're writing some test and afterwards writing some code, and you want to see how the code behaves in regard to the test regarding coverage. Let me see, there should be, let's, for example, pick one test here. And we can run the single test now, of course. Like I now use the menu, coverage as JUnit test. And this test is executed, a few test cases. And of course, this not covered at all because this was not in scope. And the overall coverage down here is also very low because we're only testing a single target, which is very hard to find to drill down here. And this is a first tip for you if you work on this kind of single tests. You have test cases. You have a lot of options here to configure this view. One option is that you can actually select the type of the root nodes. So currently the root node is project, and we can types. So now we have a long list of all types. Obviously, all of them or most of them are not covered for the one which is of interest, but that's also boring. So here's a nice option which is called hide unused elements. And if you check that, you only see what has been covered by exactly the test you currently executed, and you can directly, you see some inner classes here, but we can directly click on test. So we executed the line impl test, and here's the line impl class, and we see that it's nicely covered. We missed one case, obviously, so testing can be improved here. This is one use case. The code coverage works actually on any Java code. So currently, or the typical way to use it is to use it on your own code, the code that you just wrote or that you just tested. But you can use it on any code, like on a third-party library. And this is another use case I want to show you here. The test suite here, let's say the big test suite here before, if you go into the coverage configuration dialog options, what is typically selected by default is source folders only. So we only care about, typically only care about the source code within our IDE. But we can also select libraries. JaCoCo, so this particular library under test here, uses the ASM library. It's a bytecode manipulation library. And now I'd also check the bytecode manipulation and run coverage. Okay, maybe uncheck the other one. Here we go to packages. Here we go. Now I wanted to actually execute the whole test suite. So this is, by the way, this is nice. So this particular test we just run does not use the library at all. So zero coverage, no instruction executed at all. Of course, to run the overload test. And see how the library is used here. Running now, and the code actually uses the library a lot. So that library. So now here we are. So we see that we use 1/3 of the library itself, and we can drill down now and see the packages which are actually used by the library and how heavy they're used. Like, for example, there's an XML package, and it looks like we don't use the XML package at all. So we don't use any XML stuff with the ASM library. This is nice if you have like a bunch of libraries and you want to see how a specific component actually uses these libraries. This is if you work on a huge legacy code base and you want to see how all these libraries which are on the class path for whatever reason are actually used. You can do some impact analysis with code coverage also. This is one use case. And then there's another nice use case. It's called differential code coverage or live code coverage. So what we're currently doing is that we execute some test case or some test suite, and afterwards we have a look at the result. But we can also look into a running JVM. I show you how this works. I have the Eclipse debug UI plugin here in my workspace. Now I want to launch another Eclipse hosted within this Eclipse here. So under code coverage, of course. So I run an Eclipse application. Start another Eclipse. The whole application now is under code coverage. We see later how this works. So whatever Eclipse framework, OSGI framework, everything is under code coverage now. So every execution is recorded. Typically, the overhead which is added is very low, like something like 10%. It does starts up so slow currently, but this is a virtual machine I'm doing this presentation on. And maybe I get some issues with the resources here, should start up soon. I'll give it another second. It should be faster. you go back to the coverage view, I can show you this. We have this little symbol here, which lists all running applications currently, and we see the Eclipse application running to retrieve data from the running application. Let's go back here. We have we have a little demo class here, and what we can do, we can execute program here. We simply run it as a Java program. We run it as a Java application here. It dumps Hello World. Very simple. And we can also launch it from the menu down here, of course. And now the question is, if I'm an Eclipse developer, and if I want to see how actually this is implemented and how actually this menu is implemented, it would be nice if I could watch what code has been executed and how this menu is built here with this history items and where's this code located. And this is where live coverage comes into picture. I go back to the to my actual IDE of this running Eclipse application. Should be requested now. It is analyzed, and I have the Eclipse debug UI in my workspace. So this is the one I see, and I see that about some code in my workspace is used here. I can also sort, let's say, by X covered instruction. So where is actually the going on, and I see something going on in the internal UI. If you have noticed, maybe I had this checkbox here which says reset on dump. So I just reset all the data in my target application. So when I do another dump, let's do another dump, it's 0 because nothing is executed currently. So now I go to my application under test and open that menu again. And now I should get an idea, if I dump again, what code has been actually executed to create the menu. And if I open this here, I get something, it's called abstract launch history action. Already pretty close to understand where this is actually implemented, and I get probably something like get history. Oh, here's the history, launch history. And the history gets something like launch configuration manager. So this is nice. So I can watch a running application and see where the code, what the code is currently doing. And this helps me a lot to navigate in a huge user application like the Eclipse workbench to see how a particular feature is implemented by simply clicking the feature and afterwards seeing what has been actually executed. Our presentation and have a look at some theory behind this. Okay. To sum it up, so what can we use code coverage for? So the typical use case is for white box testing, so for unit testing. If you really take care about the specific units and the code in specific units and want to test that and make sure that this unit actually fully tested. I can also use it for integration testing to see whether maybe I missed some scenarios in my integration test, or maybe there is code which is not used at all and maybe it's obsolete and I can remove it. What we have also done is we did usage analysis. So we analyzed how a particular piece of code, like a third-party library, is actually used by a certain library. And we did the differential code coverage or the live code coverage, which was that we actually observed the running application and identified the pieces of code that has been executed during a certain action. Something to know is that the EclEmma plugin, also the JaCoCo library behind it, works basically on any JVM, any code running on the Java Java virtual machine. So it's not aware about whether the application under test is a JUnit test, or maybe NGUnit, or maybe it's some proprietary integration test, or maybe it's just any Java application you can or you can record coverage information. And we sometimes get the request, it would be nice if you get some timing information and if you get some execution counters or whatever. And so code coverage is not intended for profiling. So we have a clear focus on having a lean and fast code coverage tool for you, and we're not going to bloat it with any additional metrics like calling context or execution times. There are way better tools on the market, and JaCoCo or EclEmma is for code coverage. That's it. It's not for profiling, just as a side note, because we get many requests for that. So there are better tools that could do a way better job. Coming to metrics, so there's a number of metrics you can retrieve, calculate from the code coverage analysis, and actually you can display all of them within the EclEmma user interface. If you open the view menu here, you can switch between like instruction counters or branch counters and for the respective counters. So the most basic information we can provide is the number of covered instructions, and instructions here means actually bytecode instructions. So the little pieces we see within the compiled class files, the bytecode instructions which are consumed directly by the JVM. JaCoCo or EclEmma works on bytecode. We will learn about this. So this is this is the most basic metrics we offer, and the advantage here is that it works even without any debug information. It works on any class file you can execute in the JVM. Branches is also nice. So whenever you have a branching point, like an if statement, or while, or switch, EclEmma records the branches which has been executed and which are covered for you and shows this. And control flow and the branches, you can calculate cyclomatic complexity. This is a definition of the number of independent paths through the method, which basically form a base to all possible paths to the method. And the value of that is a rough estimate of the required number of test cases, of the required number of independent unit tests you should execute to fully cover your code. And this gives you a nice idea. If we go back to my previous example here, so let me finish the other workbench. Go back to our previous example, and if you run our again, something is slowing down here dramatically. The tool down here would show you the future down would show you the total cyclomatic complexity of your project. So you have a rough idea how many test cases you need to, independent test cases you need to get full coverage. And we also introduced a notion of complexity. So you always know, you get a number of how many more test cases you need to write to actually fully cover your code base. Here. What is, of course, more natural for the developer is lines of code. We can show this, but this requires to have your classes compiled with debug information, which is the usual way nowadays anyways. And the number of methods and the number of definition is that the method or class is covered if at least one method within the class is covered. Unfortunately. Another question I often receive is, what is the coverage percentage we should target in a specific? I always, as an answer, give this example. Imagine you have two projects. You have like a project A, which is obviously very good in testing. They have 80% code coverage. And if we have project B with 35% code coverage, it looks like, of course, project A did a way better job. But if I look at the absolute figures, that project A is way bigger than project B, and the total amount of untested code in project A is way bigger than the total amount of untested code in project B. And so I have a couple of recommendations for you how to actually work with code coverage. And the first one is don't care about percentage value at all. So observe the amount of untested code. Keep an eye of the untested code. So why is the code untested? Is the code obsolete? Do we miss important test cases here? Keep an eye of that. Especially focus on coverage on modified and new code. In particular, if you work on a huge legacy code base, it doesn't make sense to randomly write test cases at some here and here. If you need to modify the code, or if you create new code, make sure this one is well tested and well covered. Of course, code coverage should not be an individual hobby. It should be actually part of the whole workflow in the team, and it should be part of your tool chain. If you have like Eclipse, you can directly use it within Eclipse, but it should also be part of your build, which gives you more options we can see later. And don't make a secret out of it. So make it really available to every developer in your team. So everybody should get an idea about the test quality within the team. But well, don't show it to the management. So this shouldn't be an objective to get a high percentage, whatever value. Show it to the developers so they know where to actually act on. And of course, your test cases should have coverage. You should really make sure that your test cases assert the expected outcome, and the test cases prove that the units under test are actually fit for their specific purpose. Due to the wide use of code coverage, especially in offshoring project, I've seen a development practice where code coverage was just, or tests were just written for the sake of code coverage. I've seen unit tests without any assertions at all, just to produce code coverage. I mean, this is rubbish. This is just this is how you waste your time. So I don't use code, never use code coverage in this way, because just executing your code will not improve the quality. It's about the proper assertions and proper and maintainable unit tests, which actually work like a specification for the behavior of your test. Since the beginning, I'm talking about the JaCoCo library, which is actually the machinery behind the EclEmma plugin, and I want to quickly give you some ideas how this works. So what the JaCoCo library provides is a Java agent. The Java agent is basically a jar file, which can be provided to a Java virtual machine with this parameter Java agent. The agent can interfere with aspects of the JVM. In particular, it can interfere with the class loading process, modify class files. And this is what JaCoCo does. It modifies your class files on the fly to add additional information or probes that record additional information into your class files. Take, for example, this one. This is a control flow of some method. And what JaCoCo does, it analyzes the control flow and identifies strategic pieces where it makes sense to insert so-called probes and the probe actually record the fact that they have been executed. And with these probes inserted here, derive the executions of all other instructions in this method. Like if you know, if like this has been executed, you know, this instruction has been executed, and this branch here has been executed, and so on and so on. JaCoCo does it, calculates a minimum number of probes required to get a full picture afterwards. And if you wonder what the probe actually is, the probe is a couple of bytecode instructions, which basically flips a bit in a Boolean array. The probe does. So it just flips the bit in a Boolean array, so the overhead is very, very low. JaCoCo works on class files only. So the input for JaCoCo is always class files, so it does not parse any source files. Fun fact here is that JaCoCo works on any JVM language. So we have examples for Kotlin, for Scala. JaCoCo can be used for any language because it finally only sees the class files. What it does to the class file is before we execute it, it instruments the class file by means of inserting the probes. And there's also a way to pre-instrument physically the class files for some certain use cases, but default is we do it on the fly. And at runtime, there's a JaCoCo runtime, which also records these Boolean arrays we've seen before. And it writes so-called exec files. It's a proprietary JaCoCo format where the probes which has been executed are recorded. They tend to be really small. At analysis time, so in the EclEmma plugin, when the view down, the coverage view opens, the EclEmma JaCoCo library reads the class files again. It has to be the exact same class files, remember that. Combines it with the executed probes and can get a full picture what instructions, what line, what branches has actually been executed, and provides this via API or in dialogues or whatever. Having this as a background, it's interesting to see that we also have some import and export options. I could quickly change to here. And we have a couple of export options. So if we don't have a nice continuous integration set up, we can directly export a coverage session, an HTML report. I think I prepared something like this before. So this now looks like pretty much like the Eclipse browser, and you can drill down to and see source highlighting within the source code. So some kind of imports, which is also interesting. We have here run debug in the session. We can import external execution data files. If we have like an external program launch with the Java agent, the execution data file is created, we can import it here from a URL, which is interesting if you have like a build server or some server environment where the execution data file is created, you can download it from here, or you can directly connect to a running agent. This would provide live code coverage as we've seen before. Retrieve the data from a running application if the agent is configured like this. So you will find a lot of, in the documentation, you find all the options for the agent, how to configure it to allow this live control. Let's go back here. There's more integrations here. Beside the Eclipse integration, there's more IDE supported, like the IntelliJ or NetBeans. For what is nice, that for the standard build tools like Maven or Gradle or Ant, get code coverage with the same technology. So basically, you see the same figures within your Eclipse IDE than in your build. There's a lot of continuous integration. Platforms which support the JaCoCo backend. An important one is for me is also the Sonar Cube. You should keep an eye on that. I will show you an example later why. And we will have a command line interface. This will be the next release. And you can do your own integration, whatever you want, because JaCoCo is basically a plain Java API, and you can integrate it with whatever proprietary tool you want to integrate it. This is example is a screenshot from the SonarQube interface, which also nicely integrates with JaCoCo. It's basically their default coverage engine. And they have a concept of leak period. And what we see down here is, this is the overall code coverage of new lines. So as I mentioned before, keep an eye on the new code, on whatever you change. And SonarQube provides for you, it actually integrates also with the SCM and can say, okay, like for the leak period since 25 days, we have 96% of code coverage on the new lines. This is like really nice. If you remember this picture, that we always work on class files, I want to show you also some warnings and pitfalls about common problems we see in the wild. First of all is different class files at runtime and analysis. And we really have to make sure that the class files are the same at runtime and analysis. If you have different class files during the execution of the program, then during analysis, you won't get valid results. And there's a couple of reasons, like different compilers, different compiler settings that will lead to this situation. So I always recommend to really make sure to use the exact same class files. If you have like bad class passes, if you have like multiple versions of the same library in the same class path, you cannot create a report on the same class file if it's in different versions. And the other thing which we sometimes see, if the JVM is just killed in some means, like pressing Ctrl+C on Windows, the agent has no way to write out. And some frameworks who extensively use reflection may also have problems with JaCoCo. JaCoCo adds synthetic fields. Actually, they are marked as private and synthetic, and you should really ignore synthetic fields if you do reflection, because the compiler can add synthetic fields at any point in time. And sometimes these libraries get in trouble with the JaCoCo specific fields added by instrumentation. Also, if you pre-instrumented your classes, which we do not recommend, you get a requirement on the JaCoCo runtime, which has to be added on the class path. And we sometimes see problems with interoperability with other agents, especially like PowerMock, which changes the class files on the fly also and reads it from the file system. And this causes some headache to some agents like JaCoCo, which are bypassed in this situation. Maybe at the end, I want to show you quickly how we actually moved to the Eclipse Foundation, because this is the great news, especially for the Oxygen release train. We proposed it as Eclipse projects in 2016. And we had the chance to get Evgeny Mandrikov. Evgeny Mandrikov is a long-term contributor to JaCoCo and EclEmma, and he volunteered to do all the paperwork and all the technical work to move it to Eclipse Foundation. So he is our project lead. That Evgeny, and he set up all the project infrastructure, like the builds. We needed to create an update path because we just changed the namespace. We see that later. And yeah, finally, it's part of Eclipse Oxygen. We have a bunch of builds. We built against several versions of the Eclipse platform back to 3.8. See that here. And the new version will be EclEmma 3.0. We left the name. It's still EclEmma. It's included in several Eclipse Oxygen packages. It's included in the IDE for Java developers, in the IDE for Java EE developers, and IDE for Eclipse committers. It basically has the identical functionality than 2.3.3, so we did not add any new features. So the primary focus was to really make it part of Eclipse, and so also we adjusted the look and feel and made sure that it really nicely integrates. And we also added high resolution icons. So on the higher resolution screens nowadays, you also see nice icons for all the EclEmma code coverage specific icons. But it still works back to Eclipse 3.8, so we actually have integration tests for that automated. And then there's an important notice, maybe if you have created some extensions to the EclEmma project, the namespace has changed. It is now under the Eclipse namespace, org Eclipse EclEmma, and this might cause some incompatibilities to plugins that have been created for the EclEmma project itself. A couple of links, how you can get involved and get some details and get in touch. These links are also down in the YouTube description under the video. You should directly find these links, and you can get in touch and or maybe even contribute to this project. So that's for joining this webinar. It's exactly 45 minutes, how it was announced. I hope I can. Okay, Kat, where are you?
Here I am. Thank you very much, Mark.
Kat, you're back.
Yes, so I just wanted to give everyone the opportunity to join us real quick. If you have any questions, we do have about 5 minutes or so. There is one question that we received from a Dennis. So if I understand correctly, the question was, did I understand that EclEmma is coming out of the box with Eclipse Oxygen? So Mark, is that something that you're able to answer?
Yeah. Yeah, actually, we were part of the packaging project, and as I showed in my last slide, we are part of the IDE for Java developers, or part of the IDE for Java EE developers, and for the IDE for Eclipse committers. So depending on the package you download, it will be included already. That's correct.
Okay, perfect. And I'll give a few more minutes. I'll just go through a couple of housekeeping things while we just wait to see if there are any more questions. So just a heads up to everyone that tomorrow we will actually be having our next Eclipse Oxygen webinar. It takes place tomorrow, June 21st at 11 a.m. Eastern. And the subject of the presentation will be PHP development tools, so PDT 5.0 in Eclipse Oxygen with Kaloyan Rayev. The other thing that I wanted to also mention is that if there are any ideas for future meetup topics, we've already received quite a few from the community. Please email us at marketing@eclipse.org. We want this content to be driven completely by the community on topics that you want to learn about. So reach out to us, let us know what you'd like to learn more about, what's worked well, what hasn't, and we want to continue to adjust this program so that you can get the most out of it as possible. So I will just check one last time to see here if we have any questions. If you missed the opportunity to ask a question live, feel free to email them to marketing@Eclipse, or you can comment on the YouTube video. So I'm just going to mute for one moment here while I check the video to see. All right, so it doesn't seem there are any more questions. So with that, we'll wrap it up. Thank you again very much, Mark. It was a pleasure, and we hope to have you back soon for another presentation.
Welcome, and have fun with Eclipse Oxygen.
Thank you very much.
See you soon.
All right, we'll see all of you tomorrow. Take care.